Hi there, I hope you're doing well. This is my final demonstration for my GSOC 2025 project with Intel's openVINO toolkit. The project which I worked on this summer was image embeddings in openVINO model server OVMS with the final goal of having an image to image search application using vision models such as Clip, Lane, Dino for generating semantic embeddings with openVINO model server. The client uploads query images and receives similar images from pre-indexed dataset on visual context similarity. This enables applications to find visually and semantically related images without requiring text descriptions or manual tagging. The system uses Python code for pre-processing, post-processing, and the media pipe graphs for optimized inference execution. So the first thing which we'll do is we'll start the OVMS model server, and for this project we have utilized iGPUs, the Intel GPUs for optimized performance. So what we'll do is we'll first go to the project directory. Uh, all right. So as you can see, we are in the project directory now. So what we'll now do is we'll run a Docker script which basically serves the OVMS server via GPUs. So as you can see, it's mentioned in the README. This is the script which we use when we want to use it for GPUs. So I'll just run the script and let's see how this goes. Alright, so as you can see, it shows us the available devices for openVINO CPUs and GPUs. That means it's in works. So what we are now going to do is that we are just going to wait because this takes a little while to load, and so we'll just wait for it to load. Till then I'll just, yeah, okay, so as you can see it's loading. Since we are loading it on a GPU, it takes a little while to get the entire thing set up. If we were doing it for CPUs, then it would have been a lot more faster. Uh, but yeah, the loading process takes a little time for GPUs. So, right, so as you can see, it's recognizing all the models which we have. We have Clip, we have Dino and Lane, which we are using for this project. So uh, it is now initializing the graph nodes, and okay, the preprocessor config JSON file is loading. All right, sweet. So as you can see, all the models have loaded, all the media pipe graphs for the models have loaded. So as you can see, Clip has loaded, Dino has loaded, and Lane has loaded too. So these are basically the media pipe graphs which we have for these models. Now what we'll do is uh, we'll also start the vector DB. So um we need to store the image embedding somewhere. So what we'll do is we'll use a vector DB for that, and the image embeddings would be stored in a vector DB. And from there we'll perform the image to image search and retrieval. So as you can see, we ran the script. So for this project, we are using Quadrant Vector DB, which is an open source vector DB itself. So as you can see, it works fine, and the Docker container for the vector DB has started successfully. So till now, we have started the Docker container with OVMS, and then we have also started the Docker container with the vector DB. Now we'll just go ahead and we'll just start the script. We'll just see how this demo works. So I'll just run this. I'll just activate a virtual environment, and once this is done, we'll just go over here. Alright, so now I think we can run our gRPC script. So what the gRPC script does is that the gRPC script it loops over a folder of images, and based on the images the folder has, it stores all the embeddings in a vector DB. So in this project, we have a demo image folder. As you can see, this is a demo image folder. It has like random images in it. So what the gRPC script will do is that it will loop over the folder and it will store all the image embeddings in a vector DB. So we'll just run this script. All right, so this takes a little while to load though. All right, so as you can see, it's building the vector DB. It has started the process of building a vector DB. The server is ready as well, and you can see. So now we have a choice to make. We can choose which model we want. So we have three models for this project. We have Clip, we have Dino, and we have Lane. So I think for this demo we'll go with Clip. So as you can see, we have selected the first model. Alrighty, so as you can see, it has loaded. The embedding has been successfully stored in a vector DB, and you can also see some stats and some performance metrics. It tells you the number of images which we processed. It shows you the average inference time for a single image, and it also shows you the total time, which was for the entire folder, right? So now what we'll do is we'll just run our Streamlit script. So what the Streamlit script does is that it basically launches a front end through which the user can um, upload images and find the most relevant image from the folder. So as you can see, we're starting the Streamlit script. So the Streamlit script is live. So we'll just open it. Okay, so uh, it it takes a little while to load, so we'll just wait for it to load. So it is loading a little slowly. Uh, okay, let's see. All right, um, so now since the app is loaded, and you can see everything here. We have the host. We have information about the host. So now what we can do is we can choose an image. We can upload an image. So I'll just browse files, and as you can see, I have some test images here to see which image we can use. So we'll just select a random image. Let's say we select this image of a mountain. So we upload the image. It takes a little while to process the image. So mm, that takes a little while. And then also we can see which how many relevant the number of results that we want based on the image that we uploaded. So right now it's set to 6. We can set it to 18, like that's the maximum limit. So as you can see, this is the query image which we have, that of a mountain. So now we'll find similar images, and bingo, you can see these are the most relevant images to the query image in our folder, in our embeddings which we got. So this has the highest similarity score, so that's 0.7438, that's 74%. Then 0.69, 0.68, 0.58, 0.5862, and so on and so forth, right? So now what I can do is I can probably increase the number of results that we want to see. Suppose I want to find the top 10 most similar images to the query image. So I'll just scroll this over, and yep, it's set to 10. Let's do it. So now we have 10 most relevant images to our query image. So this was an example of an image of a mountain. Let's try a different one. So let's select this image. As you can see, it's an image of a lighthouse. So let's see. So as you can see, these are the outputs which we got. So this is the most relevant image to that of a lighthouse with the similarity score of 0.63, and then 0.61, 0.60, 0.60, 0.59, and so on and so forth, right? So it gives you the most relevant images it finds in the folder. So uh, now what we can do is we can select a different image as well. So uh, we'll just test it for the last image. So this is an image of a dog. So if you go over here and you find similar images, you find this, right? So the most re relevant image is that of a dog, and then uh, the second is that of a bear, although it's not a dog, but yeah, still. Um, and then we have similar images to this based on everything which we have in the query image. So this was it for this demo. So we were able to successfully build an image to image search app, and we were able to include image embeddings in OVMS. So now for the future enhancements, this can be expanded to other modalities as well, such as audio and video. And what we can do in the future is that we can also have cross modality applications like audio to image, image to audio, audio to video, video to audio, text to image, image to text, right? So all these things, they are there for future i- improvements. In the end, I would like to thank my mentors, Derek and Damien. They have been really helpful, and they have been really supportive throughout this entire coding period of GSOC 2025. And I'm really thankful for all the guidance and all the learnings which I got while working with them. And overall, it has been a really fruitful and a very nice experience.